Today, I'm going to take you through how to segment the coronary arteries using 3D Slicer in order to calculate PCAT, pericoronary adipose tissue on CCTA, as well as non-contrast CTs. To do this, we will need 3D Slicer. You'll have needed to download a VMTK slicer module into your 3D Slicer. So let's open 3D Slicer and get started. You'll find your extension browser here, where you can search for the extensions that you need. Here we have the Slicer VMTK installed. We have our two images that we are going to use here. This image being the CCTA, this being the non-contrast CT for calcium scoring. Let's start with the CCTA. So I'm going to click this top button, and I'm going to drag in the CCTA that I'd like to review. Once that's in, we can load in the images. So I'm going to start by coming up to the top bar and going to the segment editor. I'm going to add a segment, and then I'm going to come up to threshold the image. I'm going to choose a threshold that allows me to visualize the coronaries with as little noise as possible, but ensuring for full visualization. You can see the right coronary coming off here. Control scroll will make the image larger. And then we can see our left main come off here. I'm going to expand the threshold just a little bit more, because we can always manually cut it down. All right, that looks good to me. Now I'm going to click Use for masking. And I then automatically get switched into the paint function, where I'll be able to paint out the coronaries that I want to segment. I'm going to use a sphere brush and be able to edit in 3D views. And I can click Show in 3D so that it would visualize it in this screen. So let's start with the right coronary. I can make my cursor bigger and smaller using this dial, and I'll highlight over the right coronary. The goal is going to be to segment 10 millimeters of each coronary. So that should be plenty of room to give us 10 millimeters. Our reference comes from a paper where we're going to take 10 millimeters from the origin of the right coronary and then measure 10 millimeters from that of the right coronary. And then at the bifurcation of the LAD in the left circumflex, we're going to take the first 10 millimeters of the left circumflex and then leave 10 millimeters of space and take 10 millimeters of the left anterior descending artery. So we can scroll out, visualize the small segment that we've mapped of the right coronary so far. Now we want to make sure we only take 10 millimeters and we take 10 millimeters after its origin. So to measure 10 millimeters, I'm going to come up here, go to Vascular Modeling Toolkit, and use Extract Centerline. I will have to choose endpoints, create new point list, click on the point with an arrow to place your points, take your endpoint right at its origin, and then you can put another endpoint further down in the right coronary. We want the centerline curve to create a new curve. We just have to choose the surface of segmentation in order for it to work. So now we have a segment centerline curve, and all right, then you will go to markups and measurements, check off length, and you'll be able to see the length of your segment here. So we need a little bit more to get to 20 millimeters of the right coronary, and then be able to chop off the first 10 millimeters. So let's go back to our segment, choose paint, and add on more. That should be enough. Now we're going back to our vascular modeling toolkit, extract centerline. We can use the trash button to delete the last control point, place a new control point, and then click apply. Now we have exactly 20 millimeters. So now let's remove the first 10 millimeters. To do that, I'm going to shift endpoint 1 approximately 10 millimeters, where I think it's about halfway, and then re-click apply, and toggle it slightly so that we have exactly 10 millimeters. Looks good. Now we have to remove the excess segmentation that we have, which will be this segment over here. To do that, I'm going to go back to our segment editor, use the scissors, and I'm going to adjust the view and I'm going to cut off the first 10 millimeters. Perfect. You can also clean up other things with this scissors. For example, we can remove this small branch coming off. Now we've segmented the 10 millimeters that we need of the right coronary artery. So in this image, I can come back to click this button and delete our center line, our endpoints. Now I'm going to repeat those steps for the same pieces that we need for the left anterior descending and left circumflex artery to create those in two separate segments. So I'm going to come back to the segment editor, add a segment. Segment 2 will be for the left anterior descending artery. You can see here. For the left anterior descending, we are going to do the same thing as we did for the right circumflex artery and take a 10 millimeter buffer after the bifurcation and then 10 millimeters after. So here we can see the point of bifurcation. I'm going to go to thresholding, pick a threshold that works well for the artery, use for masking, and then I'm going to use my paintbrush to paint after the bifurcation. You can see that we might get in some small other areas that we didn't mean to include, and we can go to use our scissors to cut out that area. And we can see the 3D model in this top image as well. We can use our paint pen to visualize where we are. So this would be at the start of the bifurcation. This would be towards the end. You can continue to paint here to make sure that everything is captured. And now let's draw our center line. Come back to the vascular modeling toolkit, extract center line. We want to change this to segment 2 as the surface, create new endpoints. Click on the box with the point and the arrow. Endpoint 1 will be at the initial bifurcation. Endpoint 2 will be at the end of the segment that I've drawn. Make a new curve. Click apply. And our center line is drawn. In order to measure the center line curve, I'm going to go back to markups, measurements, check off length. And we've measured 23.45 centimeters. So now let's cut our segment appropriately. Remember, we put endpoint 1 at the bifurcation and 2 at the end. So we want 10 millimeters from endpoint 1, approximately halfway. Let's go back to our center line, apply. We can see now we have 11.93 millimeters. Now I'm going to use the scissors to extract only the part of the artery that we want. Go back to segment editor. We can come back to our data points and delete those. Now that we have segment 1 being the RCA, segment 2 being the LAD, let's map out our left circumflex. Add in a new segment. Our left circumflex segmentation is going to begin right at the bifurcation of the left circumflex and the LAD, and we're just going to take the first 10 millimeters. So here we see the bifurcation. Threshold, I'm going to use the same level, use for masking. And then I'm going to highlight my left circumflex. We can see it in 3D here. Let's measure it. Vascular modeling toolkit, extract center line, segment 3. We're going to make new endpoints. Tap the box to be able to place endpoints. You're going to start right at the bifurcation and then pick a spot to end further down. You can place your endpoints on the CT image or the 3D. Let's make a new centerline curve, apply, and then come back to markups, check off length to see the length. So we have just a little bit too much. Drag our endpoint to a little bit further in. Come back to our center line. 10.2 looks good. And then I'm going to go back to our segment editor, use the scissors to chop off this excess at the end. Great. Let's come back to our data, delete the endpoints in the center line that we don't need, and we're left with our 3 segments. We're all finished with our segmentation for the CCTA, so we're going to go back to our DICOM data with the purple arrows. Before I close out, I want to export the images. I'm going to edit the name of the images to match what I segmented. Segment 1 was the RCA. Segment 2 was the LAD. And segment 3 was the LCX. I'm going to rename my segmentation CCTA segmentation. And then I'm going to save my data. All we need are these two files. And I'm going to save them in the appropriate directory in the same file path that contains the images. So you can now see in my folder, I have the CCTA segmentation images here and the other file. Now let's look at the calcium score. I'm going to go back to where we can add in new data. And I'm going to drag and drop our calcium score. The only one I want to load in is the calcium score. We can pull up for viewing our CCTA to view side by side to make sure we have the right orientation. Great, let's get started with our RCA. Make sure we have the calcium scoring clicked as the image that we're going to edit. Now we can remove our data points for our CCTA segmentation because we've already exported them, and our CCTA as well, and we'll just keep the calcium score in 3D Slicer. And now we're going to add a segment. We will just use the paint tool directly. That's the button right under the mouse. Again, you can change the size of the brush here. And then I'm going to zoom into the RCA. Remember, we're using a 10mm buffer between the origin and when we start. In order to measure it, in this case, I'm going to just use a blunt ruler, which you can find up here in the top left. Start at the bifurcation and end at 10 centimeters. Because you can visualize this whole segment of the RCA in one image. So I'm going to begin at the end of our segment. With the paintbrush, I don't need the editable intensity range, but I can use a smaller brush. And use the ruler to remeasure how much this is. So I may need to go a little bit further down, but it's hard to visualize on this slice. Come over here to remove my length segments. Now let's see what it looks like in 3D. Segmentation in 3D looks less ideal because the slice thickness is much larger, but you can see that this is the piece of my RCA. Let's use our line tool to see if we can measure I'm going to start from more proximal to go to the most distal point that I've recorded. And we see that the centerline curve is 10.4 millimeters. So perfect. Now I can delete these endpoints and centerline curves, as well as the ruler segmentation that I've made. And we have our first segment done. Now I'm going to try to find my left circumflex and my LAD. Let's start with the LAD. For the LAD, we use the same 10 millimeter gap that we used in the CCTA. We are going to use our raw ruler because we can visualize the bifurcation here and take 10 millimeters down from it here. And then we will try our best to segment after that. I'm going to use the paint tool, add a new segment for this, and paint over my LID. Again, coming back to use the scissors to trim out the sides. Now let's draw a center line. On segment 2. Using the proximal point to the more distal endpoint. Create a new curve. And 0.2 millimeters. Perfect. We can remove our endpoints and our center line. And now let's go to make our last segment, which is going to be of our left circumflex. The left circumflex, again, the 10 millimeters begins at the bifurcation. Here we see the bifurcation point, and I'm going to start painting. Might need a little bit more, but let's see how much that gives us. And now I'm going to place my endpoints for my center line. Using segment 3, creating a new point list. Starting at the most proximal side and ending most distally. Let's measure the curve. 10.5 millimeters. Looks good. Let's remove our endpoint and our center line. And let's just clean up this segment to remove this excess. Now let's export our images. Let's rename this CAC segmentation. First we named the right coronary artery, then we named the LAD, and then we named the left circumflex. Now we can save these. Again, all we need is the .nrd and the .seg.nrd images. Change the file path. And you can see we have our CAC segmentation and our CCTA segmentation. It was fairly easy to visualize the LAD and left circumflex on the non-contrast image, but in the case that it's not, we can go back to our image and we can double check ourselves. All right, and that concludes the video. Hopefully that was helpful in being able to segment your coronaries for calculating PCAT from non-contrast CT.